And I want to hand it over to Steve Altizer from Copy Dynamics, who's going to be leading this session. Take it away, Steve.
Thank you very much. I'm just going to assume that everybody in this room is here to listen to the data center cooling presentation, and you're not here just for lunch. We're all passionate about the subject, and I'm glad to see so many other people are too. My name is Steve Altizer. I'm with CompuDynamics. We're a power, cooling, and network infrastructure company based about 5 minutes from here. You could walk to our office. And a lot of the folks on this panel and a lot of folks in this room are customers, friends, and partners of ours. I'm going to say a couple of things, and then I'm going to start asking some questions from my fellow panelists. So just to kick things off, a couple of perspectives from my point of view. But first, I also want to thank BizNow for allowing us to talk about this subject. For us and for many, cooling is a really, really important topic, but it's a subject that doesn't get a lot of press. It's not fancy like critical power and high-speed networks and all the things you hear about and read about all the time. It's kind of the necessary evil. It's the ugly stepchild. It's the, it's one of those things that we'd all love to do without if we could. But it's very, very important, and it could be becoming more and more important. So I'm going to allow my fellow panelists to introduce themselves and express to you guys why they're up here as well and why they feel so strongly about the subject. Go ahead, Phil.
Okay. Hello, I'm Philip Sandino. I'm the Vice President of Operations for Raging Wire Data Centers. In that capacity, I run our critical facility operations, also our infrastructure delivery for clients in our retail co-locations, security and safety, and commissioning of our new data centers. And they're going to give me something else here pretty quick. Maybe tag on. But yeah, anyway. So I'll run that for the entire corporation.
My name's Mike Herwald. Work with Munters in the sales group. At Munters, we make data center cooling systems that use different types of heat exchangers in order to harness the cooling potential of outside air without some of the complications of just bringing outdoor air straight through your data center.
My name is Craig Gearing. I am the Director of Design and Construction for CyrusOne here for the East region. I guess I'm here to present the viewpoint of the owner on the future of data center cooling. I am not an engineer. I am actually just an architect and real estate guy who builds data centers. And so most of my perspective is just going to come on what I see as cost compression, and that cost compression I think is really going to strike the cooling systems next.
Thank you, guys. I want to start this off by going back in history a little bit. For those of you who've been around the industry for a while, cooling in data centers used to be sort of a one-size-fits-all, one flavor, perimeter crack unit, precision cooling. Everybody put Liebert units over on the side of the room or whatever manufacturer they choose. But as you're driving to this event today, I imagine you drove by a number of facilities, including Phil's right next door, and you could see different kinds of cooling systems that may not have been in use a few years ago. And I know CyrusOne uses a completely different option than that, and Munters sells a different product solution set than that. And I'm just kind of wondering, from your guys' perspective, why are there so many different options in the cooling business for data centers? And by the way, let's keep this collaborative, not Q&A, okay? So you can debate with each other and that'd be even more fun.
I think Raging Wire has an interesting story because we were born out of retail with very high density. We were using water-side and air-side economization in our buildings. A lot of complexity to our systems. Now we're going towards building fast deployment. So we migrated from water-side and air-side economization to where in Texas we're using Kyoto's, and here in our Virginia 3 site that's right over here across from Ford's Fish Shack is going to be DSEs. So we're, obviously migration, for me it's better, it's simpler. I'm operations, I want simple. I want effective, and then between the Kyotos and the DSEs having built-in economization that's automated, to me that's very nice for the simplicity of our operations. So that's kind of the journey we're on, and both of the last two I mentioned, Kyoto and DSEs, bring us into a waterless environment. So for siting, we want universal siting of our designs. We don't want to have to customize a design for location, and if you're dependent on water, it's not a universal design.
Yeah, I would add that, diversity in data center cooling options is really a result of market demands. I mean, there are different owners out there that have different priorities, whether it's reliability, whether it's the lowest PUE available, the lower maintenance, higher maintenance. I know you mentioned field waterless systems. So I think the future of data center cooling will be a continuation of diversity of different solutions out there depending on the priorities of different owners. At Munters, we are fiercely focused on both wet and dry solutions for free economization, to minimize compressor usage and minimize the mechanical system, or maybe more than minimize, but maybe eliminate the mechanical system completely. And we see great traction in the marketplace for, Phil, as you said, the dry option, which would be keyed against ambient temperature, and the wet option for the owners that really want to harness even more free cooling from the ability to harness against ambient humidity, which really can boost the cooling potential in every area based on weather conditions.
So diversity of technology, that's what's on the table, Steve?
Yeah, whatever you want to talk about.
Okay. So what we're seeing, I mean, we're really using one standard of technology because we're looking at the present, and the present right now is, building at scale very, very quickly. The other present that we have is this issue about cost compression. We are constantly, my big joke about whether it's data center cooling or anything in the data center, we quote a lot of movies in our project team. I think one of our favorite movie quotes is from It's a Wonderful Life, if you remember that scene. Who likes It's a Wonderful Life? Remember that scene? George is sitting with his dad, and he goes to his dad, Dad, I don't know if I can live a life in a shabby little office looking for 3 cents of savings and a length of pipe. Well, guys, that's our industry now, right? Because at scale, we buy an awful lot of pipe, and our customers are coming to us for cost compression, because if you look at the scale of how this industry is growing, it's growing at like 25% a year. But if you look at the spending's growing at 2% a year. And, so I think the diversity of technology is going to be grown by the people who are looking at the divergence between those two growths and figuring out that equation for their own business model. How do you drive down the incremental cost of capacity of data processing, for your technology? And I think for the owners, we're going to go with the technologies that do that effectively, but also are able to do it at scale.
So cost is important. First cost is very important to CyrusOne. I know that from dealing with you guys. But if you look around, these data center cooling systems cost, they have different costs, and they have different operating costs. And I'm curious, Phil, for example, your DSE choice doesn't seem like a first cost question. Maybe it's more of an operating cost question. So trying to get the energy costs down and keep the operating flexible.
Yeah, so flexibility is a big thing because the customers that we're going to be putting into VA3 are probably going to be very different. We'll have a mixture of both retail size and then wholesale, taking down whole vaults, and they have very different requirements across the two. So the way that our building is separated, it's separated in megawatt chunks. And it'll be one of our first designs to do that. So it's purpose-built to be delivered at the wholesale level. And then, again, it's simplicity. It takes an environmental piece out of the equation, and not having cooling towers and all the chemistry and everything that comes with that is very important to me, again, as an operator, because we don't want to be, it's just, I don't want to have more experts and more consultants and more services pegged to cooling towers.
Yeah,
If I
Mike,
need to.
Mike, what is your view on cost? I know that your system and other similar systems to that, Kyoto and others, are not the most expensive to put in, but they also yield good energy performance. So how do you balance the two, or how do you sell this to your customers, this balancing the two?
Well, Steve, we've got spreadsheets that would scare the shoes off of anybody in this room that look at ambient conditions, look at utility rates, look at different things that are consumed in the process of cooling the data center, and develop an energy cost, whether it's a mechanical partial PUE or actual dollars. We've got a lot of different ways to analyze that. And with our product, it's all about the proposition of we're not the cheapest solution, but we want to be the most efficient solution. So, for enterprise owners that are in it for the long haul, they're very interested in present value. They're very interested in payback and long-term investment. And for the companies that lease their space, we've seen competitive advantages for lower cost of cooling for the companies that lease to tenants that they can lease at a lower cost. So, whether it's data center cooling or any form of HVAC out there, the trajectory over the last 20 years has been consuming less energy and doing more, with less. And we don't see that slowing down in data center at all. In fact, it's accelerating. And I think companies like Munters and DSC and Kyoto, we're all looking at latest innovations that will take us to those next levels, and get those challenges accomplished very efficiently. There's a lot of things going on out there.
Craig, in our preparation for this event, in our extensive preparation for this event, which was one conference call last week, you had some interesting comments about, Phil wasn't on the call, about the architecture of data centers and about the future of cooling might rely on not just IT technologies and users' needs, but rethinking the whole architecture of the data center. Can you expand on that?
Yeah, well, I'd love to because I'm an architect, and so I just go into data centers all the time. And my grandfather was an electrical engineer. If you go to my LinkedIn page, in honor of him, I kind of have his old electronics lab. And looking at that, you just realize, we've been stacking heat generating electric devices in metal boxes since the 50s, right? And I think it's time that that gets revisited. Because if you're looking at the entire cooling problem, from the server out to the environment, you kind of realize that if our industry is going to drive things globally, we just need to look at that. We need to look at that geometry. Does it really make sense to, number one, stack things in a box, then stack those boxes in another box, right? And then, all we're really doing is trying to, in small ways, solve the problems that we're creating. And I think we need to go back and look at heat dissipation, from the server all the way out to the environment and rethink that. My joke is that I really think we need to hang servers like bed sheets on a clothesline. And then you would, if you did that, you would really just have three plenums, right? You would have a cool air plenum, you would have the heat generating server plenum, and then you would have a hot exhaust plenum. And if you start thinking that way, then actually density can maybe even be an advantage, because now the heat generated by those servers in high density can maybe start driving their own ventilation flow, right? And you're getting more useful work out of the power that you're putting in to drive the servers, and not having to put more heat and power into the system, right? Which is kind of like counterproductive to cool the heat you put in, with the servers. And I think that's a challenge, to the industry to start rethinking that. And also, if you look at ASHRAE, ASHRAE is like a bullseye, right? You have the inner circle, the outer circle, and then, 5 layers of circles. if you took another tack to it, and you took the world's climates and you put it on the psychometric chart, and you said, instead of having all of these heat circles for our ash rate, and you say, well, why don't we design a server that's optimized for hot, humid climates? Why don't we design a server that's optimized for arid, hot climates, right? And instead of having like the attitude that we're gonna, somehow use the building and cooling systems to mitigate between what the servers wanna do and the atmosphere is doing, maybe we need to start taking different tacks on strategy. And since we're becoming a global industry, I think that's gonna be part of the challenge for the industry, and certainly part of the challenge, for people who are designing cooling systems. To get, to look at the challenges of water use and, to really drive a solution that better couples outside environment and server or chip performance.
So one quick thought before I get to another question about the trends in the industry. It seems like everybody's driving toward the elusive 1.0 PUE, and in order to get there, you virtually have to eliminate cooling from the equation, right? And cooling is becoming more and more compressorless in some facilities and for some applications, and the IT manufacturers appear to be driving things in that direction, and if ASHRAE and the IT folks have their way, cooling will become really ventilation one of these days. But I'm curious what you guys see with your acquaintances and tenants and friends in the business and what you see in the trends. There's a lot of hyperscale users out here, particularly in our market. Are they driving a different need than the traditional colo customers? Are you seeing a widening of the spectrum of needs, and how are you handling that? This is kind of a bunch of questions all in one, but I'd like all of you to answer that if you can.
One of the really practical things I was thinking as Craig was talking was, I just think in terms of diminishing returns. Is you design something, you deploy it, and then it depends on what you do with the IT at that point. It depends on what the client does inside the cage, inside the rack, and it also depends on what somebody does inside of their own vault. And it requires good teamwork between, in my case, and I guess in Craig's case as well, good teamwork between the data center owner and then the clients who are in there. And even then you make some assumptions and misassumptions, and then you have somebody actually deploying the technology and into racks that are wide open. And we see servers spun backwards, and we see cables kind of mismanaged and no blanking panels. And so there could be a lot of great talk about coming down to this perfect place, but it's both ends of it. You have an SLA in place with the client, and you're both meeting those obligations, or thinking that you're meeting the obligations, but it's only going to get so far, and until you actually have the deployed end of it is done properly. That everything is spun in the right direction, that stuff isn't loaded into the middle of a rack. And it sounds like detail, but there's so many of these details I get into working with my clients, and I want all of our clients to be very happy. I want them to be satisfied with it, and I want it to be very, very energy efficient. But a lot of client complaint comes, and we'll go and look at it, and then give them a summary of what is actually deployed, and they don't necessarily know because maybe the third party did it for them. But it's great thoughts, but practicality of it, that's my end, is operations, is practically people have to do their job at the end of it to make it work.
Yeah, I'm going to pile on exactly what you said. So, I'm giving you guys the crazy future, because what Steve said, what's the future of cooling? My answer is there's no future of cooling, right? The future of cooling is a PUE of 1, right, which is no future of cooling. So
That would suck.
Yeah. Yeah, to bring in another joke, right, guys? The futures is plastics, right? So, but we find, right, because we're working with partners at scale, that they want to come in and tinker with the system, right? Because they're looking at, they are actually looking at their rack deployment, and they are looking at things, and they have their ideas. So, as we're joking, construction's becoming a customer experience. because our customers are very hands-on in sort of fine-tuning the technology. We also, and I know because we're talking, the HJ is coming in and fine-tuning the technology. Building on the west is entirely different than building here in data center-friendly Loudoun County. Thanks, buddy, wherever you are.
All where they're selling something.
All of this is, part of the future of cooling. Everybody's going to find, I think, their own answer, and there'll always be room for everybody because there are customers that have unique situations. But there are some driving trends, and this, for me, it's this trend on cost compression. There's this, trend. I say there's a trend against water, right, because of the risk of water. And there is this trend of, finding the right system for the right scale and locality, right? Because we're looking at, we're an air-cooled chiller-based typology, but in certain localities and with certain customers, we are being forced into, not being forced, but encouraged to look at other technologies, right?
Sure.
And I heard you saying, Raging Wire is in the same sort of position, right?
Yeah, I mean, we're asking the market what it wants, and then that's what we're going in with. That's what we're trying to do.
And we're somewhere close to that. We have our position, but it doesn't mean we're not flexible and amenable, right? To as we say, making the sausage a little bit different, because in the end, what's driving the industry is really this tremendous scale, and delivering at scale, and delivering incredibly quickly at scale. And that's something I think everybody needs to, we're all challenged by. And I know, how have you been impacted by scale, like on your production side?
We have a long history in HVAC, and as we become a bigger and bigger data center company, we found not too long ago we just can't do the other things anymore effectively. That's how much different the data center world has been for our production. So it's an extremely challenging scenario when you're trying to evenly load a production facility. We've got several hundred people that build air handling systems, and the size and velocity of these jobs is a huge strain on every manufacturer that is catering to the data center market, whether you're making cooling equipment or generators, or I think it's tasks to everybody out there in a good way. So we welcome the challenge. We have changed the way we do business to the point where we're exclusively data center today. At every level, we've had to really do that, as probably same with other companies too. Big change.
So we've been talking about the big cloud colo facilities primarily, but one quick comment about on-premise data centers. In our business, we have a tough time sometimes dealing with customers who want to start with a low-density situation and increase to a high-density solution at the end. So you got to build flexibility into the design and the construction. And I imagine that's similar to what you guys are faced with all the time, because you've got some customers are 2 kilowatts a rack and some want 25 kilowatts a rack. And how do you deal with that? You got one big space, and in some cases you're putting several customers in that same space, and you have to be able to accommodate them.
From an equipment standpoint, the idea of economization systems, great turndown is an inherent part of that design. So they kind of naturally fit the ability to run at 10% initially and ramp up to 100%, because number one, the compressor runtime or the mechanical cooling system runtime is so small. Number two, it's minimized. So when you're a mechanical person, when you start running into limitations on the low end at which you can operate, it's typically going to be your compressors and things like that. So we've been able to accommodate that naturally with the solutions that we brought to market. It is tough though. I mean, if you're looking at a traditional way of cooling a data center and you've got, let's just pick a load, you got a 10,000 ton load, and on day one you got to do 100 tons, and you got 10,000 ton chillers. It's going to be really, really difficult. So I realize we're unusual in that aspect, but that's the answer that we have. It's easy for us to do with our system.
Well, I think your first customers are going to be really happy. Because they're gonna have infinite airflow, lots of panel space, lots of floor space. It just seems like options are there. So initially, everybody's good to go. I think
So
that,
the first guy in benefits from all that real estate.
yeah, it's just, there's nobody around. They're going to get all the air. They're going to get everything they need.
Do they not pay a penalty on energy?
I guess it depends on how their contracts are pegged. I've got a salesperson here somewhere that throws something at me if I try to speak to that. But no, we don't penalize customers. But you're paying pass through, so obviously the energy rate's going to go down when you hit a higher threshold of power that you utilize it more. What you said you're going to utilize, your cost per unit goes down. But I think to that point we were talking earlier, there's later when you start to get full, that's when we're trying to maximize our ability to sell things. We have 3 types of real estate. We have floor space, panel space, and cooling. And so you're trying to make all those, you're trying to wind all of those down at the exact same time. And so you don't want to run out of panel space and then still have a dance floor, that's unsold. So trying to maximize those things, and you're trying to sell initially, so you're happy to get people in there, but then you say, oh, wish I'd have turned them sideways, or wish I'd have sold something a little bit differently. So I think the pain comes a little bit later on.
Phil, are you and Craig seeing more and more customers that have a definition for day one load, but they are forcing you to design for a 2-year from now load? Are you seeing more and more of that, or is that?
I think that I'll just take a stab at it first, Craig. They're if it's a wholesale, they're knocking down a whole vault. So whatever they're taking behind the doors, it's do whatever you need to do. It's yours.
So that's all we see, right? So we just, I think everybody understands around here, we just delivered, we're on the verge of delivering over 1 million square feet in 18 months, right? 70 megawatts. There's a ramp up for all of those customers, so part of our typology is about decoupling the power and the cooling and the space so that we can manage the incremental costs going up. I mean, a lot of our focus is on managing the incremental cost of capacity. And then, metering in our investment, like, in chiller blocks. So our cooling capacity is decoupled from our power capacity. So, we can ramp in, we do 4.5 megawatt blocks. We can ramp in our chillers, so we don't have to buy all of our chillers on day one. I mean, we have a system where, as load grows, we can ramp it in. We can ramp in additional equipment on the floor, and that's part of our strategy. We have very, very simple one line. So, but like you say, that's ramping in is just part of the business model now.
So we have just a couple of minutes left, and I'd like to open the floor if somebody has a question for one of our panelists up here about this very, very important topic. Please, Bruce.
Bruce Edwards with CCG. Thank you, John. So far, the discussion really is centered around an air-cooled solution to the device. But I'd like to know the panel's view towards water cooling direct to the device, or very closely coupled to deal with the ever higher load densities per rack that we're certainly going to see in the future. You may not see it now at your hyperscale facilities in the commercial sector, but we're certainly seeing it in some of the more specialized applications, which we anticipate will flow down to the commercial sector in a few years. So I'd like to see you understand how you view that aspect of cooling.
If I could just kick this off real quick, I'll try to be brief. We have some partners that manufacture products in that business too, and we're told that the IT equipment manufacturers are bringing in ships to load into their equipment that are so hot that they have to increase the size of the box to allow more airflow through the box to cool it. And the solution to that is putting on-chip cooling systems, direct contact cooling systems. And I haven't seen a large adoption of that, but in certain applications, I think that's quite a possibility. And if the colo facilities are capable of adapting to that, that would be a big bonus for you.
We do it. I mean, if you ask for it, we do it. We've done it in some of our facilities. We see it with what I call our STEM customers. You know, the ones who are doing, you know, high density HPC, high performance computing center stuff. And we've had the, I know she's not gonna want me to do, but Kayla, you know, Kayla Remington from CyrusOne, she had a mineral oil cool system in her facility. But it's a specialized application. It's not something I don't think you're gonna see at scale.
Any thoughts, Mike? We done? One more question? Anybody? Steve? Oh,
Yeah,
put it
sorry.
this way.
Sorry to steal. Yeah, okay, well, I'll ask the ticket. Yeah, I know you guys are operating pretty locally, but I'm just curious, what are the thoughts about moving geographically to places that it might be easier to cool or not so dependent upon moving air and water? Move north, I guess, is the question.
I think I'll leave that up to you guys.
We go where our customers take us.
Same.
From an equipment standpoint, the question you ask has huge implications because, I mean, what we design for in Ashburn versus what we would design for in the Dalles, Washington. I mean, it's amazing what you can do in a different climate. So it should have huge way on where where data centers are built, but you guys have other factors that you have to design around.
I'd just like to say thank you to everybody on the panel, and thank you to BizNow, and thanks for your attention. It's been fun, and I'll turn it back over.